Hello everyone. In this session, we will be discussing about isometric projections. Now, isometric projections comes in unit number 4 in your syllabus. Okay. I hope that you are by now reasonably comfortable in the topics which we have discussed so far till development of surfaces. Now, let us move on to isometric projection and start discussing its principles and the other concepts. Now, to understand the principle of isometric projection, let us assume a cube such a way that this cube is placed on the horizontal plane with its edges inclined at an angle of 45 degrees to the vertical plane. Okay, in such a scenario, you will be having the reference line like this. As I just mentioned, I have drawn a cube such that the edges are making 45 degrees to the vertical plane. Okay, now get the front view of this cube. It will be looking like this, right? Now you there will be diagonals, isn't it? So make sure this diagonal is kept horizontal. Make sure this diagonal is kept horizontal in such a way how your front view will look like. You try and redraw the front view such that horizontal, the diagonal of the cube is placed horizontally. Can you able to imagine such a scenario? So after getting the front view, make sure uh, that one of the diagonals, preferably the diagonal which I had shown just now, is kept horizontal to the HP, and then redraw the front view, get the corresponding front top view as well. Under this scenario, if you rotate the entire solid by 90 degrees towards you, okay, you will be getting a view something like this. This is a very interesting kind of position. So I just repeat again, the cube is placed such a way that the edges are making 45 degrees to the vertical plane, and I am getting the front view, and I am making one diagonals parallel, one of the diagonals parallel to the HP. In such a scenario, I will be redrawing the front view, and then I will be rotating the entire front view towards me. If I do so, I will end up with a picture something like this. Now, this is a very interesting view of the same cube. You can easily see that all the three front faces are of same area, that is 1, 2, and 3. These are called isometric planes. Now these planes are of same area, and these edges are called isometric axes. Okay. Now, so what this means is when you want to see a solid with equal importance to three mutually perpendicular directions, then you preferably keep the solid in this particular position. That is, the corresponding base inclination will come around 35 degrees 16 seconds, 35 degrees 20 seconds or so. But the easy way of representing this is make the diagonal of the solid parallel to the HP and redraw the front view, and then rotate the front view taking one of the resting corners, rotate the front view by 90 degrees such that you can able to see the solid. If you do so, you will end up with this particular position. So this is the base for the isometric projections. So that is the meaning for this name ISO, giving equal importance to all the three front faces. Okay, so now the edges of the cube will be foreshortened in this view such a way that they will be foreshortened by a factor of 0.82 means if you have the true length as 100 mm, if you 100 mm in the case of cube, edges of the cube, then if you draw following the procedures which I just told, you will end up with an apparent view of 82 mm. That is, it will be foreshortened to 82%. So that is what isometric length or isometric scale is. So now that is, suppose if you have a true line, if you have a true line like this, say 100 mm, draw this true line at an angle of 45 degrees with respect to reference line, and this is your isometric length. Then this line length will be 0.82 times that of this true length L. That is what this isometric scale means. So that is the effect of that inclination which you are giving to the base. Okay. So approximately, if you give the base inclination as 35 degrees, and then if you rotate the solid by 90 degrees towards you, you would end up with this particular position. So the same is what the logic we are going to adopt for any other solid, just to get the isometric view. Isometric view again means giving equal importance to three mutually perpendicular directions, just to make sure that we are viewing the solid reasonably with equal importance to all the three directions. Okay, so now isometric view and isometric projections are two different terminologies we normally go and use in the case of isometric projections. Isometric view means you won't do the isometric drawing by only keeping uh, the length in the case of isometric drawing equivalent to the true length. Okay, whereas in the case of isometric projection, you convert the linear dimensions by multiplying with a factor of 0.82 into isometric equivalent isometric lengths, and then you proceed. So in the question paper, sometimes they may say isometric view, draw the isometric view. Sometimes they may say draw the isometric projections. So if it is isometric view, we should keep the true length as it is. If it is isometric projection, then we should convert that into the equivalent isometric length, and then we have to proceed. Because in both the cases, we will maintain that isometric angle of 30 degrees. Okay. So this is very important understanding we must keep. For example, you can see here that this is a example which says construction of a building, a layout. You can easily see the concept of isometric projection in this particular diagram. All these lines are drawn with 30-degree inclination with respect to the horizontal line. If you carefully watch, every single entity is being represented by applying the concept of isometric projection. You can able to see here, right? So this is even the roads, even the tree-like images, all are drawn following the isometric projection. Now, this is another example where you again have a picture which is represented based on the principle of isometric projection. You can easily able to pick the 30-degree inclination here, here, wherever you can see in the picture. The 30-degree inclination is maintained. Okay. This is another example how isometric concept is being used to draw the various three-dimensional objects here. If you carefully watch, even a single information is drawn as per the isometric projection principle. You can see here, 30 degree inclination is maintained. So these are all some examples for isometric, the application of isometric projection. Now let us come back to our discussion. So as I said, uh, true line will be foreshortened by a factor of 0.82, and that is called isometric length. If you apply this particular logic of placing the solid on HP and giving an inclination of 30 degrees to the base and rotating the entire solid towards you, this is the simple logic. Based on this, we are going to start doing the problems. You will see one by one. So with this understanding, let us go and discuss about isometric projections of various entities. Let us start with a rectangle. Say we have a rectangle ABCD of dimension 100 by 70, and we are going to draw the isometric projection for this rectangle. Now in the first case, the rectangle is placed vertically, resting on one of its sharp edges, and then it is um, trending towards the left side. Similarly, the same rectangle is placed vertically, resting on one of its shorter side, and then again it is trending in the right hand side. And then the third case, the rectangle is placed on the horizontal plane as a whole, like this. So in the first case, what you have to do is, since it is resting on this particular corner D, draw a horizontal line, pick a point on this horizontal line, mark it as D, then draw a line like this at an angle of 30 degrees, that is AD, equal to the line length AD. And then from here you drop a vertical upwards for length of AB to get B, and then from B drop a line at an angle of 30 degrees to a horizontal line. This should be 30 degrees, and then get C, and then from C you drop a perpendicular downwards to D. That will give you something called isometric projection or view. If you draw with the original line length, then you call that as view. If you draw with the isometric scale, converted using isometric scale, then you call that as isometric projection. So that is the way you have to get this isometric. Similarly, for the isometric drawing trending towards right side, you will adopt the same procedure. Now if the entire rectangle is resting on the horizontal plane, then two of the edges have to be given with 30 degree inclination. Okay, as shown here, this is two sides are given with 30 degree inclination, and then of course the length have to be maintained. If it is projection, go with the reduction by 0.82 factor. If it is view, draw with the same original length. So as far as length is concerned, you just transfer from the given diagram. So this is the way you have to get the isometric view or projection of a rectangle, right? So the point here is that you are keeping an angle of 30 degrees to either one of the edges or to two edges, depending on whether the what you call the entity, or in this case a rectangular sheet, is placed. If it is vertically placed resting on one of its edges, you will be giving the inclination 30 degrees to one of the edges. If the entire solid is placed on the horizontal plane, the entire plane is placed on the horizontal plane, then to get the isometric what you call representation, you will give 30 degree inclination to two edges. That is the difference. Right, now we will get into, so now let us pick another example. Here I am about to draw the isometric what you called views of a pentagon. Now other than square and rectangle, for other objects like pentagon, hexagon, circle, you need to enclose the entire lamina in a minimum size, say square or rectangle needed by the particular entity. In this case, I have a pentagon. So pentagon is enclosed in a minimum size rectangle. Okay, minimum size rectangle, something like this. So taking the profile of the rectangle, we are going to get the isometric view or projection of the pentagon. Now, if the pentagon is vertical, you have to draw like this. If the pentagon is placed on the horizontal surface, then you have to draw like this. Of course, resting corner matters. In this case, it is assumed that the entire pentagon is resting on this corner one of the square which you have the rather rectangle which you have drawn. So procedure is quite the same what we discussed just before, how to draw a rectangle. The same procedure you have to adopt. Once you encompass the entire entity, that is in this case pentagon in a rectangular square, then you start getting the isometric view or projection for that rectangular square, and naturally you will end up with the isometric view or projection for the particular entity. In this case, for example, since one is made as the resting corner, once you place one, then draw a line at an angle of 30 degrees, which is equal to length 1 2, and then once you get to drop a perpendicular upwards for length equal to this much 2 to 3, and then likewise complete the rectangle and transfer every single point that is of the pentagon, that is in this case A is here, A B C, based on its position on the particular what do you call it. For example, A is placed at this much distance, isn't it, from 1 on the line 1 4. Same, you take the measurement and then transfer to the corresponding what we called line in the isometric projection. That's all. Okay. Likewise, you have to transfer every single point to the isometric view. So to come again, I just give you one example now. So A, to transfer A, what you have to do is take this measurement of A to 1, and in the isometric view from 1 give the same what we call the measurement and mark A. That's all. Same way you have to transfer the other points. Okay, now we are going to draw the isometric projection of a pentagonal pyramid with the basics which we have understood so far. Now, to draw the isometric projection of a three-dimensional solid, the very first step you have to do is you have to get the simple front and top view, and then we have to go for drawing isometric projection. Let us say in this example that we are given with a pentagonal pyramid of base edge length 50 mm, and one of the base edges is perpendicular to VP and is resting on its base on HP. The height of this pentagonal pyramid is say 100 mm. This is the information related to the dimensions of the pentagonal pyramid. You are asked to draw the isometric view of this pentagonal pyramid. Let us see how we are going to do this. So as per the informations which I just shared, draw the XY line, get the top. This is quite easy. Name the base corners. Okay. Name the apex as well. Projector, draw the projector lines. You know the height, so draw the axis line. Get the front view. Name the base corners as well as the apex. This is quite okay. This is projection of solids, simple cases. Now we are going to draw the isometric view of projection. So uh, before getting into the isometric view of projection, you have to first enclose the pentagonal pyramid in a minimum size rectangle that is good enough to cover or encircle the pentagon base of the pentagonal pyramid. So now I have enclosed with a rectangle. I think you can able to see this is quite light in color. This one I have enclosed with a rectangle, and name the corners of this rectangle. Okay, so I have named it as 6789. The reason is I'm going to discuss another problem after this where I'll be having cut points in the front view. I reserved cut point 1, 2, 3, 4, 5 for that, so it will be easy for us to discuss when we come to that particular problem later. So I named the corners of this rectangle which I used to enclose the base of the pentagonal pyramid as 6, 7, 8, 9. Okay, now you have to draw a small horizontal line like this, and preferably I have picked 7 as the resting corner. There is a reason you come to know when I discuss the next problem. Time being 7 is the resting corner. So taking 7 as the resting corner, I have completed the isometric projection of the rectangle which I used to enclose the base of the pentagonal pyramid. Now I have to transfer the corner points of the base pentagon to this rectangle in the isometric view of projection. So how I can do that? See, as far as you try and assume some direction convention, let us say this as x direction, let us say this as y direction, let us say this as z direction. This is for our understanding, because to trace some points you need x and y information. To trace some point you need z information. Okay, you will see that. Now as far as base corners are concerned, of the pentagon is concerned, you have to get x and y information, that is sufficient. Why? Because yes, these are all base corners which are lying on the base, so z is 0, so no need to worry about the height of a b c d e. You are just have to transfer a b c d e to the isometric view. How to do that? Let us go one by one. For example, let us pick point a. Okay, point a is at this much distance from the corner point 6 and is resting on the edge of the rectangle 6, 9. Correct? Now this direction I have taken it as this one I have taken it as 5. So on the line 6, 9, let us say this as 5 in the case of isometric projection. Obviously this should be x. Okay, so take this measurement using your compass. From 6 to transfer the distance and mark point A in the isometric view. Right? Same way you have to trace the other point or transfer other corner points to what you call isometric view. So let me erase all these things. So now I have given the information to transfer the corner points to the isometric view of the rectangle which you use to encompass the corner points A, B, C, D, E. So likewise, if I transfer the other points, say B, C, D, E, this is how I will get the points in the isometric view. So you take the measurement using your compass from the top view and transfer to the isometric view. I again reiterate that I interchangeably using isometric view or projection in this presentation. That while to draw isometric projection, you have to get the isometric length, which is 0.82 times that of the true length. To draw isometric view, you will make use of the true length as it is. Sometimes in the question you may be given with a question of getting the isometric view, sometimes isometric projection. It's up to you to carefully look into the question and draw the view or projection. So now I have transferred the points, isn't it? The points are A, B, C, D, E. Now in this case, since I am saying isometric projection, let us say if A is at a distance of say 5 mm from 6, then in the isometric view also A is at a distance of 5 mm from 6. Okay. Similarly, the other points. Okay. Suppose A is at a distance of say 10 mm from 6. If it is projection, 10 mm I have to transfer. If it is sorry, if it is view, 10 mm from zero point 0.6. If it is projection, 10 into 0.82, 8.2 mm I have to transfer. So you must keep this thing in mind. Okay. So I repeat, for isometric view, you have to make use of the true length. For isometric projection, you have to convert that into isometric length by multiplying the true length with 0.82 factor. Okay, I got the base corner points. The next is I have to fix the apex. To fix the apex, let me first trace the apex O in the top view. So it is here. That is quite easy. If I know these two distances, I can transfer. So I have transferred by getting those two distances. Okay. Right. Once you got the image of the apex, from that particular point, we have to get a line equal to the height of the solid. Of course, height, as I said, I have to get it from the front view that I have assigned as Z direction. So take this measurement of O from the baseline to transfer it here. Okay, that's all. You will be getting O. So O is traced in the isometric view. Once you get O, you connect all the base corners to the apex O like this. Right. Just draw a line from O to A, O to B, O to C, O to D. O to E and O to B seems to be overlapping here. Right. Now, in the case of isometric projection, we will normally won't show the hidden lines. So hidden lines have to be removed. So I remove the hidden lines. So what you want to do is, while drawing the isometric projection, you use 2H pencil. You trace the solid using 2H pencil, and then depending upon the edges which are getting hidden, which are visible, you make use of HB pencil to thicken those visible lines. Now I have completed the isometric projection of a pentagonal pyramid. So how I have done that? I drawn the simple front and top view. I enclosed the base of the pentagonal pyramid using a rectangle, and I named the corners of this rectangle. I had chosen one of the corners of this rectangle as the resting corner. I first got the isometric projection of this rectangle, and then I transferred the corner points of the pentagon base of the pentagonal pyramid A, B, C, D, E just by getting their relative positional information from the top view to the isometric view, and then I trace the height of the apex point O, getting information from the front view, and then I join every single base corner to the apex point O, and I have removed all those edges which are hidden. This is called isometric projection of a pentagonal